Welcome to Intrinsic Intelligence YouTube channel. As part of array series, today we are going to solve searching an element in a sorted and a rotated array. So consider an array which is sorted and rotated. It could be any number of times rotated, and we need to find the given targeted element. If the element is not present, we return -1 as usual. So we will look into the examples first before we deep dive into the actual coding part. In the first example, we see 5, 6, 7, 8, 9, 10, and then 1, 2, 3. So key is 3. So 3 is at index 8. So 5 is at index 0, 6 is at index 1, 7 is at index 2, 8 is at index 3, and it goes on, and 3 is at index 8. Similarly, we in the second example we have 3, 5, 1, comma 2, and the key search key is 6. There is no 6 in this array, sorted and rotated array, hence we are returning -1. In the third example, we have 33, 42, 72, 99, and the key is 42, which is at index 1. 33 is at index 0, 42 is at index 1. Hence, the result is 1, and 42 is found at index 1. So let us go into the live coding session to find how we can solve this problem. I have created a solution class. I have created a search element method. I have also mentioned time complexity and space complexity here. We will come to this at the end. And I have public static void main. This is a array which is sorted and rotated, and which is rotated several times. I have created and called this method now, and I am passing integer and the array. So input array and the targeted element. So here the targeted element is at 5, which is at index 1. So we should return 1. But before we didn't have any logic, we will check whether this initial code setup is correct. And we are good to start with the actual logic part. Yes, so it prints element is present at index -1. We are good, and we will go into the coding part. First, we will initialize the variables. Let us initialize a left variable as 0, and then a right variable as array dot length of -1, and let us use a while loop to go through the entire. We'll not go through the entire array, but we will see how it goes. If left is lesser than or equal to right, now we have to find the middle element. So what I am doing is I am trying to find the middle element. If array of middle is equal to target, we will simply return mid. Here mid is the index. Else what will do? Now the actual logic starts. So this is an array. So we need to find which side we have to search. Hence, as per this binary search logic, we'll not go through the entire array. We'll go through the part where the element is present. We will identify it through the mid element, and the iteration repeats. Now, what we will do if let's see if the middle element is greater than left element, which is meaning if the middle element is something 8 is greater than the left element, then we will look into this path, or else we have to look into this side. So for that we need to look for right middle. If mid of array is greater than, right, which means yes. So the middle element, which is 7 or 8, is greater than 1. Hence, we should look for the element here. We will do that. If target is greater than or equal to num or array of mid and target is greater than middle element. Target is greater than middle element and lesser than right, then left equal to mid plus 1, right equal to mid minus 1. In the else part here, we should also do if target is less than or equal to, yeah. So basically what we are doing is we are splitting which side of the array we need to search. So through this, uh, first we are checking if the middle element is a target, then returning the middle element index. Else, if the middle element is greater than right, so we are searching through the right one, and let us run the program first. Yeah. So we are searching 5, which is target 1. So we have achieved the desired result here. So the time complexity is order of log n, and the space complexity is order of 1. Order of log n, basically it is a binary search. We are tweaking a bit. Still we are not having iterations near to order of n, meaning we are not iterating every element in the array. So we have achieved this, and thank you all once again for your patience and time for watching this video. Please do post in the comment section like what are all the problems you guys would like to solve, and I will analyze and come up with a better solution. If there are better solution than what we discussed here, please do comment that solution as well in the comment section. Thank you once again. Have a very good day.